In this problem, I have the cube root of 64 y to the 7th c cubed t to the 5th times the expression yct all to the negative 2/3 power. Now, I'm going to start with the second expression. Right now it has a rational exponent, so I'm going to convert it to a radical. So we're going to leave the first radical alone, so we have the cube root of 64. And I'm going to put my variables in order alphabetically. C cubed, t to the 5th, y to the 7th. And if I convert this to a radical, now when I'm converting to radicals, my denominator becomes my root, so I have the cube root. My numerator becomes the exponent, so the negative 2. And I'm going to have c, t, and y. So since I have a negative exponent here, I'm going to take the inverse of this second expression. So we're going to put the first expression over 1 just to make it into a rational. So we have 64 c cubed t to the 5th y to the 7th power over 1 times, and since I'm moving the entire expression to the denominator, it's going to be 1 over the cube root of c t y, and I'm going to square the entire expression. So the negative 2 becomes a positive 2 because we reciprocate it, move it to the denominator. Now I'm going to multiply straight across the top. I'm going to multiply straight across the bottom. So multiply the numerators together, multiply the denominators. So the cube root of 64 c cubed t to the 5th y to the 7th power over, I'm going to write this out twice since it's squared, cube root of cty cube root of cty. So we're going to multiply these two together. That gives me the cube root of 64 c cubed t to the 5th y to the 7th over the cube root of c squared t squared y squared. Now, since I have a rational expression with the same roots, so they both have cube roots, I can simplify just like any other rational expression. So I'm going to cancel out two c's, I'm going to cancel out two t's, and I'm going to cancel out two y's. So I'm left with the 64 stays in the numerator. If I go to my c's, I have 3 on the numerator, 2 on the denominator, 2 of them cancel out, so I have 1 left in the numerator. I can cancel out 2 t's, so I'm left with t cubed. And I can cancel out 2 y's, so I'm left with y to the 5th power. So now, since both expressions are multiplied together and simplified, now I'm going to break down this radical with a factor tree. So let's start with the 64. Since I have a root of 3, I'm looking for triples instead of pairs. So we have 8 times 8. 8 breaks down into 2 and 4. 4 breaks down into 2 and 2. So I have a set of 3 2's. Same thing with this 8. We have 2 and 4. 4 breaks down into 2 and 2. Another set of 3. Okay, so those 2's go to the outside of the radical. So I have 2 times 2. Then I go to the variables. So the c does not have a set of 3. So if I try to break it down, it doesn't have a set of 3, so it stays on the inside of the radical. T cubed, if I would show you how to break it down, we have 3 of them. So t times t times t. I have 1 set of 3, so t goes to the outside of the radical. And then I have y to the 5th. So if I have y to the 5th, I have 5. So I have 1 set of 3 goes to the outside. 2 of them stay on the inside. So I have y to the first, because the cube root of y cubed is y, and then I have a y squared that remains. So if I clean this up, I'm left with 4t y times the cube root of cy squared.